Welcome to True Projects. In this video, we are going to explain about the project title Darknet Traffic Detection and Categorization using Autoencoders. Before diving into the execution, let me give you an overview of the project. Let us understand what Darknet traffic is. Darknet traffic refers to internet activity that occurs on hidden networks not accessible through regular web browsers or search engines. Imagine a secret club meeting happening in an underground tunnel where only members with special invitations can enter. Similarly, darknet websites and services are often used for illegal activities like buying and selling drugs, weapons, or stolen data because they offer anonymity to users. For example, someone can use darknet traffic to access a website where they can buy illegal drugs without being easily traced by law enforcement. So, in this project, we are going to develop an efficient system that can detect and categorize darknet traffic, which can reduce cyber threat and safeguard data. Signature based detection, anomaly based detection, and traffic analysis are the traditional methods used in this project. But these traditional methods have limitations in handling novel threats and encrypted traffic. To overcome these limitations, in the base paper, the author integrated convolutional and LSTM autoencoders with XGBoost for darknet traffic detection. This improves classification accuracy. We have proposed a model named voting classifier for the detection and categorization of darknet traffic, which is an ensemble method which combines decision tree and random forest. The project involves two prediction tasks: binary classification and multi-class classification. Binary classification differentiates benign from darknet traffic, which is crucial for threat identification. And multi-class classification detects diverse network activities like email, browsing, P2P communication, and more. These are important for categorizing network traffic, enabling proactive security measures and targeted threat mitigation strategies. The project evaluates performance using metrics like accuracy, precision, recall, and FN score to determine the effectiveness of different approaches in darknet traffic detection and categorization. The project accurately detects and categorizes darknet traffic, benefiting network security professionals, researchers, and organizations through proactive threat mitigation, data protection, and regulatory compliance, advancing cybersecurity technologies for broader community benefit. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. In this project, we have built these algorithms to compare with the proposed model, which is voting classifier. A voting classifier is an ensemble learning technique that combines predictions from multiple base classifiers to make a final prediction. In this project, it aggregates individual predictions of random forest and decision tree classifiers through a voting mechanism where each classifier's contribution is weighted equally, resulting in a final prediction that reflects the consensus of the base classifier. Decision trees analyze features extracted from network traffic data to classify instances as normal or indicator of darknet activity. Random forest is an ensemble of decision trees which further enhances classification accuracy by aggregating predictions from multiple trees. This ensemble approach aims to improve the overall accuracy and robustness of the classification system by leveraging the diverse modeling approaches of the constituent classifier. Now, let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the dataset folder. Let us open it. This is the Darknet dataset, which comprises raw network traffic data from Darknet sources, with each entry representing a unit of network activity. Features include flow ID, SRC IP, SRC port, that is source port, destination port, protocol, timestamp, and packet length, inter-arrival times, and header information. This is the data set. And here, these are the labels of the data set, which is audio streaming, video streaming, P2P, that is peer-to-peer communication, email, etc. This data is used to train and evaluate models for detecting and categorizing darknet traffic. Pre-processing steps are applied to extract features, filter noise, and prepare the data for input into the model, aiding in pattern identification for different types of darknet activities. So this data set is pre-processed. In this project, we have done prediction using binary classification and multi-class classification approaches. This is the binary class classification dataset. This is the processed dataset for binary class classification. So here we can see the features, that is backward packet length minimum, flow IAT mean, flow IAT minimum, backward header length, backward init win bytes, forward segment size minimum, ideal max, and here we are having the label that is 0 and 1 since it is a binary classification. It tells us whether it is a benign or darknet traffic. And here, this is the multi-class classification dataset. So this is the process dataset of multi-class classification. So here we can see the features, that is backward packet length minimum, flow IAT minimum, flow IAT minimum, backward header length, backward init win bytes, forward segment size minimum, ideal max, and here we have the labels for multi-class classification. Multi-class classification is used to detect various types of network activities like email, audio streaming, browsing, chat, file transfer, peer-to-peer communication, video streaming, and voice over internet protocol VoIP. These predictions aid in accurately categorizing network traffic, facilitating proactive security measures and targeted threat mitigation strategies. These are the model files which contain algorithm information which will be loaded into the project code during runtime. These are notebook.ipynb files. These are Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. Here we need to enter all these details to register. But I have already registered myself. So click on sign in. So here we need to enter the username and the password. Which are static. After entering the username and password, click on sign in button here. We have logged in successfully and we are redirected to the prediction page. So here we can see a prediction link. We can do the prediction using binary class classification and multi-class classification. First, we will do the prediction using binary class. So click on binary class. So here we need to enter all these parameters. Before entering the parameters, let us understand the parameters. So the first one is backward packet length minimum. That is, this refers to the minimum size of backward packets observed in a flow. It represents the smallest packet size in the backward direction within the flow. Coming to the next one, which is flow IAT mean. That is, flow inter-arrival time mean represents the average time between two consecutive packets in a flow. It indicates the average duration of time gaps between packets within a flow. Coming to the next one, which is flow IAT minimum. Flow inter-arrival time minimum represents the minimum time observed between two consecutive packets in a flow. It signifies the shortest duration between packets within a flow. Backward header length. This denotes the total size of the headers in backward packets within a flow. It provides information about the cumulative size of header information in packets traveling in the backward direction. Backward init win bytes. That is, it refers to the initial window size advertised by the receiver during the TCP connection establishment phase. It indicates the maximum amount of data that the receiver is willing to accept initially. Forward segment size minimum. This represents the minimum segment size observed in forward packets within a flow. It signifies the smallest data segment size observed in packets traveling in the forward direction. Ideal max denotes the maximum ideal time observed within a flow. It represents the longest duration of inactivity observed within the flow, indicating periods where no packets are transmitted. Now, we will enter the values of these parameters to differentiate benign from darknet. So here I'm entering the value for backward packet length minimum, which is 0. Flow IAT mean is 229. Flow IAT minimum is also 229. Backward header length 20. Backward init window bytes 1047. Forward segment size minimum 20. And ideal max is 0. After entering the values, click on predict button. So here we can see the result. There is an attack detected and attack type is benign. So a benign attack is a harmless attempt to test a system's security without causing damage or disruption. Click on prediction link again. Click on binary class classification. So here we will enter another set of parameters. So here backward packet length minimum is 0. Flow IAT mean is 42744.18. Flow IAT minimum is 0. Backward header length is 40540. Backward init Windows byte is 65535. Forward segment size minimum is 20. Ideal max is 1.45633E plus 15. The given input will be pre-processed in such a way that it aligns with the format expected by the trained model. Now click on predict button. So here we can see we got the result. There is an attack detected. Attack type is Darknet. A Darknet attack is a cyber attack associated with hidden online networks involving illegal activities like malware distribution, data breaches, and hacking services. Now click on prediction link, click on binary class. Let us enter another set of parameters. So here, backward packet length minimum is 0. Flow IAT mean is 359. Flow IAT minimum is 359. Backward header length is 20. Backward init Windows byte is 0. Forward segment size minimum is also 0. Ideal max is also 0. After entering these values, click on predict button. So here we can see we got the result. There is an attack detected. Attack type is benign. In this way, by entering the parameters, we can detect the attack type as benign or darknet. Now click on prediction link. We will do the prediction using multi-class classification. So click on multi-class. So here we need to enter these parameters to detect diverse network activities like email, browsing, P2P communication, and more. So here I'm entering the values. Backward packet length minimum is 0. Flow IAT mean is 229. Flow IAT minimum is also 229. Backward header length is 20. Backward init Windows byte is 401047. Forward segment size minimum is 20. Ideal max is 0. After entering these values, click on predict button. So here we can see the result. There is an attack detected. Attack type is audio streaming. Now click on prediction link again. Click on multi-class. Now we will enter another set of parameters and check the network activity. So here, backward packet length minimum is 372. Flow IAT mean is 467. Flow IAT minimum is 467. Backward header length is 8. Backward init Windows byte is 0. Forward segment size minimum is 8. And ideal max is 0. Now click on predict button. So here we can see we got the result. There is an attack detected. Attack type is audio streaming. Let us enter another set of parameters. Backward packet length minimum is 0. Forward flow IAT mean is 179. Flow IAT minimum is also 179. Backward header length is 20. Backward init Windows byte is 981. Forward segment size minimum is 20. Ideal max is 0. Now click on predict button. So here there is an attack detected and attack type is browsing. Now again click on prediction and then click on multi-class. Backward packet length minimum is 0. Flow IAT mean is 8617143.1. Flow IAT minimum is 23. Backward header length is 60. Backward init Windows byte is 4547. Forward segment size minimum is 20. And ideal max is 1.438 E plus 15. After entering these values, click on predict button. So here we can see the result. There is an attack detected. Attack type is file transfer. Let us enter another set of parameters. Zero. Flow IAT mean is 75233.6. Flow IAT minimum is 11. Backward header length is 92. Backward init Windows byte is 980. Forward segment size minimum is 20. And ideal max is 1.437 E plus 15. Now click on predict button. So here we can see the result. There is an attack detected. Attack type is video streaming. Again, click on prediction link. Click on multi-class. So here I'm entering another set of parameters, which is 0, 549933.8. Flow IAT minimum is 52. Backward header length is 913. Backward init Windows byte is 20. Forward segment size minimum is 1.456 E plus 15. Ideal max is 0. Now click on predict button. So here we can see the result. There's an attack detected. Attack type is video streaming. In this way, just by entering the parameters, we can detect diverse network activities like email, browsing, video streaming, audio streaming, P2P communication, and more. Binary classification and multi-class classification tasks aid in precisely categorizing network traffic, enabling proactive security measures and targeted threat mitigation strategies. Let us enter some more sets of parameters. Click on prediction link and then click on multi-class. So here I'm entering another set of parameters. Backward packet length minimum is 0. Flow IAT mean is 227,833.6. Flow IAT minimum is 44. Backward header length is 52. Backward init Windows byte is 913. Forward segment size minimum is 20. Ideal max is 1.456 E plus 15. After entering the values, click on predict button. So here we can see there is an attack detected. Attack type is browsing. Click on prediction link. Let us enter another set of parameters. Backward packet length minimum is 0. Flow IAT mean is 7835.5478. Flow IAT minimum is 0. Backward header length is 59652. Backward init Windows bytes is 287. Forward segment size minimum is 20. Ideal max is 1.437 E plus 15. Now click on predict button. So here we can see there is an attack detected. Attack type is video streaming. Click on prediction link. Now click on multi-class. Let us enter another set of parameters. Backward packet length minimum is 0. Flow IAT mean is 42983. Flow IAT minimum is 38984. Backward header length is 40. Backward init Windows bytes is 980. Forward segment size minimum is 20. Ideal max is 0. Now click on predict button to detect the attack type. So here we can see there is an attack detected and attack type is P2P, that is peer-to-peer communication. Click on prediction link. Now click on multi-class. Let us enter another set of parameters to detect the attack type. So here backward packet length minimum is 0. Flow IAT mean is 267.66. Flow IAT minimum is 46. Backward header length is 72. Backward init Windows bytes is 229. Forward segment size minimum is 20. Ideal max is 1.43 E plus 15. Now click on predict button. So here we can see there's an attack detected. Attack type is video streaming. Click on prediction link again. Click on multi-class. So here I'm entering another set of parameters. Backward packet length minimum is 0. Flow IAT mean is 2449.8765. Flow IAT minimum is 0. Backward header length is 24432. Backward init Windows bytes is 1118. Forward segment size minimum is 20. Ideal max is 1.437e plus 15. Now click on predict button. So here we can see the result. There is an attack detected and attack type is video streaming. In this way, by entering the parameters, we can detect different network activities. Detecting network activities like browsing, email, streaming, file transfer, peer-to-peer communication, voice over internet protocol, and more enables organization to enhance security, ensure compliance, optimize performance, and facilitate incident response.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.